Hi, and welcome to lecture number 3 of the MATLAB portion of the course. We are already familiar with manipulating arrays. The last lecture, we did several exercises where we input numbers into an array, manipulated arrays. Hopefully, we'll feel a little more comfortable doing that. And what I want to do in this lecture is show you a way of running scripts. Now, we're gonna be dealing with scripts in many more occasions here, but I just want to kind of give you an introduction so you can see how this is really useful. And we're also going to be obviously using what we learned so far, and we're going to also introduce you to some new techniques and some new functions. So let me first start by sharing my screen. All right. So before I start, I want to remind you again, remember the input function? We talked about the input function where we can use it to create more interactive scripts and programs. We also use the display function to display values that we and information that we think should be useful in running the program. There's also another one function that I want to introduce here is the number to string NUM2STR function, which is a very useful function for making a number into a string so you can display it on the screen. Okay, and again, if you ever need help on any of the functions, you can do this and you automatically can see information on it. But like I said before, this function num2str will convert a number to a string. You'll see how we use it in a specific script that we're going to do. I also want to talk about a little bit about the for function or the for statement. How is it used to do things that are repetitive in the program? And it's typical of any other language, right? It's a for statement that you go through several iterations until you find something that ends it. And that concludes the for statement. There's nothing really different from any other language. So let me give you an example. For instance, if we have for statement, you start the for statement with an FOR and you end it with an END. Okay, so that's how the system understands where you're starting the for statement and when you're ending the for statement. And then we have an index. The index could be any variable, right? And of course, you have a start and an end. In this case, we're going to go from 1 to 5. There's two ways of doing this. I can do this in one single line, or I can just press return at this point, and nothing happens because the program, the system is expecting an end statement. Until it sees an end statement, then it's going to recognize that I'm finished with it. But in the meantime, I'm just going to do X. I'm going to manipulate this number, and I'm going to just add 1 to the previous value of X. That's all, simple like that. And I'm going to choose to display the value of X at every iteration. I don't have to do that, but just to show you. And then I'm going to end it. So that the end statement finalizes that segment, okay? So I'm initializing the index at 1. I'm going to increase it from 1 until I get to 5, but at every point, it's going to increase X by 1. Of course, at this point, I haven't haven't defined a value for X. So let me just copy this. And since I don't have a value for X, it's gonna take, you know, the value that was already on the, in memory. So I'm gonna clear this, okay? So I'm gonna start fresh, and then I'll let X be equal to, I don't know, 2. And then I'm gonna run the program now. I'm gonna run the script, right? So I saved it, and I'm gonna just, you know, cut and paste. And then you see how the for statement works, right? It's very simple. It's like, again, like any language, computer language has basically the same type of for statement. So again, X begins at 2, that's my initial value, and then every iteration is going to increase it by 1 until it gets to the end. So at the end, it's going to be 5 plus 7, okay? So, so that's how the for statement is used, right? Very simple. All right, so now I'm going to introduce you to scripts, okay? And scripts are just little programs that you can run at any time. If you have something that's repetitive or something that you want to run a later time, you can just save it. In MATLAB, the scripts have a file extension M. So that M indicates that it's a MATLAB script. And the way you start script is just by saying new script. If I click on new script here, it opens up the editor, as you can see. And I can start typing here, right? And start typing the commands that I want to have in the script. And when I'm ready to test it, as we go along, I'll show you all the features of the editor, because you also will be able to debug more complicated scripts using this editor. You can create breakpoints, you can run only selections of the script if you want, and do other things, okay? But in the most simplistic way, you're gonna just create a script and click on the run and run it and see what it does. So hopefully we'll do what you expect it to do. Okay, so so what I'm gonna do is I'm gonna call a script that I already wrote. Let me just close this. But again, if you want to create a new one, you just go, let me close this. From the home menu, you will create new script, okay? If you already have a script, like in this case, I have a couple of scripts I'm going to show you in this lecture. So I have already created those scripts. If I just double click on them, it'll open the editor automatically. And you can see on this one is just a basic, very simplistic script that will convert a radian frequency into a hertz frequency. That's all. That's all it'll do. So as you can see, it's always critical. It doesn't matter where you're programming, as you already know, to add comments in the proper place, right? So right here, I'm saying, well, this is my frequency conversion script, all right? And I'm using the input function so that I can enter the radian frequency. So I'm going to enter the radian frequency, and I'm going to save it in W. And then I'm going to simply use the equation for converting the radian frequency into hertz frequency, and I'm going to display it. And when I display it, I'm just going to say frequency in hertz is, and here's where I use the num to string function, because this number here at this point is a number, right? And I want to display it as a character. So I'm basically converting the number to string so I can so the display statement can display it properly. Okay. All right. So and that's it. That's a simple, very simple script, like I said, but it gives you an idea of what a script is and how they run, right? Very simple. So that means that I can recall it every time I need it, every time I want it. I can have it inside other scripts. I can have it inside major functions, major program, and use it as I please from now on. That's the beauty of it. Okay. So again, I have saved this. And by the way, when you start writing the script, if you start writing it and don't save it, but try to run it, the program itself is going to ask you to save it. So the very first time you write a script, you're going to have to save it, give it a name, and the extension will pick up by itself. It's extension M because it's a script. So so that's it. I mean, this is a simple example. So I'm going to run it, right? So I'm going to click run, and it's going to run this script. Okay, script W2F, and it's asking me to enter the radio frequency. So I'm going to enter the radio frequency as 377, and it's going to give me the frequency in hertz, right? So it displays the number enter because I didn't, I didn't put a semicolon in there, but you could if you want, so you don't have this information there anymore. And so it displays the frequency in hertz, and I can run it again. If I run it again, it'll, enter a different frequency. I'm going to enter 125, and it's going to display the frequency in hertz. Very simple, right? But that's what a script is, and that's what a script does. Okay? So I'm going to close this script, and then I'm going to use another one. And on this one, I'm going to show you the for statement and how it can be used, okay? So in this for statement, I have two ways of running this because I'm also introducing a couple of the things, a couple of the functions that are useful when you run this kind of programs. And I just want you to pay attention to this section for now, okay? And what I'm going to do is, just for the sake of it, I'm going to get rid of this for now to keep it simple, and then explain it later why I have it in there too. I'm going to get rid of this for now, okay? All right. So what this function will do is simply is going to take a number, okay, and is going to get the number multiplied by 2. That's all. That's all it's going to do. But it's going to do it 10 times, okay? And so it's going to use a for statement, and the for statement is going to start at 1, and it's going to end at 10, right? So the very first time, it's going to ask for the x value. What is the value of x? I'm using the input function for that. And then it's going to say, well, start at index 1, and then the first time that it sees that index is going to multiply x, the value of x times 2, and it's going to return, it's going to increase the value by 1, so now it's going to be 2, so it's going to take the previous value of x multiplied by 2, 3 multiplied by 2, 4 multiplied by 2, and you get the picture, right? So it gets to 10. When it gets to 10, it's going to perform that last multiplication by 2, and then it's going to end because it reached the last value of the index. And then I'm going to choose to display x at the end. I could use, I could display it in between. In fact, let me just do that for now. If I have it inside the for function, it's going to display every value of x that it sees when it's being multiplied. So let's try that. And then on the second version, I'm going to display just the end result at the very end of the last index. Notice that I'm skipping one line here and one line here. I'll play that in a minute. And then at the end, I'm going to display the time it took this little script to run, okay? The time it took to run. And the way I do that is I use this function clock, okay? And what it does is clock just basically takes the time, the real time when this is running, it saves it, and I'm going to save it, I'm saving it in this variable t0, okay? And then at the end of the for statement, I'm going to take that that value that I originally recorded, and then I'm going to clock again, and this function e time is going to subtract the two values together, the last clocking that it did and the original clocking that I did at the beginning of the script, of the for statement. And so this TF includes the final value. The value it took when clock first run to the value it saw at the end of this for statement, just to see how long it takes to run that for statement. And then I'm going to display it. So I'm going to display the time in seconds, because this function eTime is going to give me the difference between the initial time and the final time in seconds. And again, I'm going to put a num to string function here, so I can take that number and display it as a script, as a string rather. Okay, and that's all there is to it. So let's run it. Okay, so I'm done with it. I'm just gonna click run, and as you can see, I included that clear C at the beginning so that everything is clear when I start. See, I have that as the very line in my script, right? So everything starts clear, and I'm gonna enter the value of X. I'm gonna enter 2, and I'm gonna hit enter, right? And then you see at that point it displays all of the values of X, right? Because it's displaying all the values of X when it's multiplied by 2. So you can see 4, 8, 16, and so forth. So the final value you're gonna see after the 10th iteration is gonna be 2048. And it's telling me that it took 20.384 seconds to run, okay? Now, it probably took longer because I have this clock before I input the number. So if I move that, I can, well, before I do that, because I have something on memory that I don't want to erase, let's just keep it that way, and then we'll play with that a little later. But you saw how that works, right? If I take the display X outside the end statement, you will see that now it's not going to display every single value of X inside the for loop, but it's just going to display the very final value. So I'm going to run it again. Run it again, and clear the screen. I'm going to input, I don't know, 6. And as you can see, it just shows me the final value of X after all the indexes have been completed, right? The total iteration. And this time it took 4.931 seconds. Okay. All right, so that's all there is to it. There's also another way to manage time, and instead of using the clock, okay, there's another technique that is very useful actually, which I happen to like better, and is using 2 functions, the tick-tock function. Okay, very simple. And all it does is when you click tick at the beginning, starts like timer. Okay, and when you want to stop, you say talk. So that's it. You start the timer with tick, you stop it with talk. And so what we're doing here is exactly the same program, the same script, right? We haven't changed anything. The only thing that changed now is the way I'm gonna compute the time, okay? But notice that at this time I have the tick after I put the value of X, right? Because if I put the tick before, like I did in the previous script, see how I have the clock before I input the number, then the time it takes to enter the number is being taken into account. So it's not really computation time. It's just really time, it's waiting. So if I take 10 seconds for me to enter that X, it's going to count those 10 seconds as part of, the time it takes. So, it's just to give you an idea of, sometimes it's very important for you to maybe figure out where you're spending a lot of time in the program. In this case, however, in the second iteration of the same program, the same script, I have the tick after I enter the X. So that's a little more realistic, right? Because I don't have to account for the time it takes me to enter X. So let's run that again. And this time I'm going to just start. I'm going to start from here. I'm going to. I'm just going to use the second version using the TikTok. Okay. So I'm going to run it. And again, I'm going to clear the screen. I'm going to enter the number just like before. And I'm going to enter 9 this time and then 10, and see how, see how long it took this time. Okay. A lot lower than before, right? Because I had the tick after, I input the value. The time it took me to input the value was taken into account before. Okay. But there's nothing wrong with it. It's just, how you choose to account for the time the program is going to run, right? Okay, so the main thing here is to show you the use of the for loop, right? With initial value for the script for the index and a final value for the index. I could have also chosen to, instead of going from 1 to 10, I could have used it because in this case, it's taking the increase as 1 by default. But I could have just gone, every 2 values like this, and then, affect the result a little differently. So if I run this now, and I'm going to enter 9 again for X, then you see how the final value is affected, because now is skipping, right? Going from 1 the first time, the second time is going to go to 3. And if you want to see it, we can put this inside the for statement, right? I'm going to run it again. And again, I'm going to use 9 just for consistency. And now you can see, right? It took the value of previous of X that I have 9, right? For the first time, multiplied by 2, right? And then it took that number and multiplied by 2 again, the second time around, but it skipped, right? Because it went from 1 to 2, then from 2 to 4, 6, 8, and finally 10. And that's it. And that's how you can not only run a script and make changes on the spot, see how we do it here, test it, see what happens. Later, I'm going to show you a lot more things you can do with scripts, but for now, you can see how really powerful they are. But now you can see how you can quickly, just type a real decent script and use it for later. In fact, if I close the script, right, and go back to my my desktop, if I just call the script, right, if I say script, and I call this one for, that's it. If I type it, it runs. It's asking me for the value of X. I'm going to enter 6, and there you go, right? So I can call the script from within the desktop, or I can call it from within another program, another function, another script. In fact, I'm going to show you this one. Okay, I'm going to call from script that I used to convert radian to hertz. I'm going to at the end call the script FOR. Okay, so I'm going to save that. And I'm going to just enter the radian frequency, 377. Oops, sorry. Remember that. Okay, I'm going to enter the radian frequency. And as you can see, I didn't need it. I wrote the M extension just because I'm used to writing the extension, but you don't need it because it recognizes that this is, being that it's not a built-in function, being that it's not something you have previously defined, it assumes you're running the script. So you can see this here. He went directly to the script. Now, if I go to the script this time, I'm going to the FOR script. And just to show you how it can run from within another script, because if you remember, this script here has a clear C statement, and that's why we didn't see the what do you call it? We didn't see the previous line for, or the previous result for this other script. So I'm going to save this like this. I'm not going to clear the screen, but I'm going to go back to the script that computes the hertz frequency, right? So let me try that again. And for clarity purposes, I'm going to clear the screen myself. So everything is from scratch. And I'm going to run the script radian to frequency conversion, right? So it's asking me for the radian frequency. I'm going to put, I don't know, 75. And it gives me the hertz frequency. And now see how it's waiting to run the next script, right? It's asking me for the value of X. I'm going to enter 3, and that's it. So this shows you again that I can run scripts within scripts, right? This is very powerful because you can use scripts, in any way you want to run within any other program, right? Very powerful. Or you can run them from the command line like this, the desktop, right? I'm gonna get rid of that statement here so I can save it as I had it before. I'm gonna go back to this one. I'm gonna put a clear C just so that I can have it consistent like I did last time. I'm gonna save it. And then I'm gonna show you another example, okay, for script, which is a little more involved, I guess. Not difficult, but a little more involved. So let me close this. And I'm going to show you another script, okay, which is a little more what you'd be doing maybe with this kind of script, right? On this one, we're going to use a script to calculate the instantaneous and the average power of an AC voltage and an AC current, right? So that's the problem, right? The script is going to calculate the instantaneous and the average power. Let me clear this here so we're looking at a fresh script. So as you know, the instantaneous power is just the product of the instantaneous voltage and the instantaneous current. The instantaneous voltage is defined as a cosine wave with a magnitude Vm, a frequency here given in radians, and a phase, theta V. I'm using theta V for that. And the current is also defined as a sinusoidal with a magnitude Im running at the same frequency at an angle theta I as a phase. Right? Now the plan is, okay, so the plan is the following, right? This plan is always something that also your book is very strongly suggesting, is that you follow a plan. Okay, don't start, scripting or programming just immediately. You see this equation and you want to start just typing in and run it. Come up with a plan and implement the plan one step at a time. Make sure everything is covered, right? So in the plan, right, and this could be different. It doesn't have to be this way, but you have to have some kind of plan, some kind of way of organizing the information, right? The first thing I'm going to do is I'm going to enter the values for the voltage amplitude. the phase voltage, the current magnitude, the current phase, and the frequency. Okay? Those are the 5 things I need to calculate what I want, to get what I want. Then the second thing I'm going to do is I'm going to calculate the value of the voltage, right? The sinusoidal voltage, and I'm going to plot it. Then I'm going to calculate the sinusoidal current and plot it. Then I'm going to calculate the sinus or the value of the instantaneous power and also plot it. And finally, I'm going to get the average power, right? And so I start with step number 1, right? So step number 1, for step number 1, I'm going to use it a little bit interactively. So I'm going to ask the user to enter that information. And later we'll see things that how we can make this better, right? You can make it interactively so that it never ends unless the user tells you to end it. And many other ways. You can maybe have a file somewhere that already has this information, is collecting information, and all you gotta do is call that file, so you don't have to enter information and so forth. There's many ways that we're gonna improve on this and expand on this. But for now, we're gonna do it interactively. We're gonna enter those parameters on the screen, okay, and then just to get some reinforcement, we're going to display those values on the screen. The values for the magnitude, for the voltage and the current, the values for the phase angles, right? And so, and maybe we should display the value for frequency as well. So I'm going to have the value for frequency here. All right. So we're going to display all those values, right? And now, so that's the first thing I'm going to do. Now, I have to choose a time frame for this, right? So depending on what your frequency is going to be, then you're going to have to choose the time that you want to display, right? The first time I'm going to run this, since I'm going to use a frequency of 377 radians, which translates into 60 hertz, just in this first time, just to show you what's going to happen, which translates into 60 hertz. Then with this information, I can see with this timing on the x-axis, I can see a couple of cycles, right? But remember, this you're going to have to keep track of if you want to see information on the screen, because depending on the frequency, then you may have to modify this time to see what you want on the screen. Okay, I hope that makes sense. Again, later you'll see ways that you can interactively and automatically modify the time so you can see the information on the screen. But for now, we're not there yet. I'm just trying to capture something on the screen given this time. If it's not good enough, I can always change it, right? I can come back and tweak it until I see something that is useful. Anyhow, that's the first step, right? I'm entering all the parameters. And then the second thing I'm going to do, like I said, is I'm going to calculate the value for the instantaneous voltage and the instantaneous implied, right? Because that's what I want. So, so I have the value for V, which I'm saving the value for the instantaneous voltage in the variable V. So I'm going to take the amplitude that I input here, and I'm going to multiply by the cosine of omega t plus the angle that I enter for V. Okay, I'll explain what this is in a minute, the figure statement here, and then I'm going to plot it. Okay, and I'm also going to explain what this is, the hold on figure statement here. So I'll explain that in a minute. For now, just concentrate on this. I'm I'm calculating the instantaneous voltage and I'm plotting the time versus the voltage, right? The next step is I'm going to do the same thing for the current. I'm going to take the current amplitude, the current frequency, and the phase. And I'm simply going to just use this simple equation and calculate the time, the current. And then I'm going to plot it again, with the time that I was originally set up here. I'm going to plot the current, okay? And then obviously the next thing I'm going to do is I'm going to calculate the instantaneous power and plot it, right? And all I got to do here is multiply, right? And since these are vectors, right? I'm going to have to use a dot. Multiply the voltage that are generated here times the current that are generated here and plot it again, right? And then the final thing I'm going to do, which is part of the plan, is I'm going to plot the average power. If you remember from AC circuits, the average power is 1/2 the product of the voltage magnitude and the current magnitude times the cosine of the difference between the two phase angles, the voltage and the current. And multiply by pi and divide it by 180 because remember this is in radians the way it is. I'm going to put it in degrees. So when I take the cosine, I'm taking the cosine of a degree figure. And then finally, I'm going to display the average power using the DISP function that I used before and using the num2string function that I've used before because this number here, I'm going to make it into a string with this function so I can display it. And that's the end. So let me, so I covered the 5 steps, right? Remember, the only thing I haven't explained yet, and let me save this so I can click here and save it and just save. Before I run it, the only thing I didn't explain to you was about this figure and hold on, right? Well, notice here how I have figure commented out, right, every time. If I include figure in here, what will happen is that every time I say figure, it's going to generate a separate plot, okay? So this one here will generate a figure for this voltage. This one here will generate a figure for the current, and this one here will generate a figure for the power, okay? Separate figures. Now, if I want separate figures for each of those parameters. But if I want everything to be plotted on the same plot, on the same axis, I can use this function that's called hold on. Hold on does that. It just plots a function over a one figure over another figure on top of that figure using the same axis. And these are just options, and you'll see in a minute how that works, okay? So let's try it, right? So I'm gonna run it. So it's asking me to enter the frequency. So I'm gonna put 377 as the frequency. It's asking me to enter the magnitude. So I'm gonna put 4 for the voltage magnitude. It's asking me for the current magnitude. So I'm gonna enter 1 for the current magnitude. It's asking me for the phase voltage. I'm gonna put 45. It's asking me for the phase current. I'm gonna enter 60. And there you go. That's it. Now it's showing me the numbers I entered, right? This is, and again, you can make this much better to read, right? And this is just the first time we're running this. As you can see, this is the value of the voltage amplitude, the current amplitude, theta V, theta I, and the frequency, right? That's what I got. So I could have formatted nicely and actually say it, what it is and so forth. If you need to, you can do that. It's not difficult to do. All right. And and then it tells me what the average power is in watts. Okay. For this particular case. So now the interesting thing here is to look at the plot, right? So we have let me clear this because I think I have one extra more than I wanted. Oh no, it's fine. We have the, as you can see here, right? We have the uh, voltage, right? The voltage has an amplitude of 4. This red one is the current, which has an amplitude of 1, magnitude of 1 rather. And then the yellow one is the instantaneous power, right? So that's basically the result, right? We know what we got. Now, the ways to make the plots look better and nicer, if you will, using the plot statement, but also if you want, you have an option. You can, for example, let me expand this a little more so you can see. Once I got the plot, right, I can go into the edit menu here and say, for example, I wanna look at the axis properties, right? And one thing I can do, for instance, I can put a title over the plot, right? Like if I want to save this for later, I want to put it on the paper or something, right? I can start playing with this the way it looks, right? And I can do other things. I can, if you, for instance, if I double click or click on one of the figures, right? I can change the colors. So when I make this blue, well, maybe not blue because it looks like the voltage, but I can make it, this color now. And I can also display a name for that one. So this one, I happen to know is the current because remember the current has a magnitude of 1, but I can say it and save it, right? And later you'll see how we can see that because if I click on this window here, it says legend, now it says that the blue corresponds to a current, and I can move this also around. See, so in a way, I can generate a very nice plot after the fact, right? And then save this. So other things I can do, right? If I go on this one, right? I can change the name. This one, of course, is my voltage. I'm gonna change it to voltage. And as you can see here, the legend now tells me what the blue is, right? It's the voltage. If I want, I can change the color. Let me make it red, so it's more obvious what the voltage is, what the current is. I can change the width of the type of the line, like if I want it like this, right? Or if I want it like that, or and so forth, right? You can change, you can change how you want it to look like. I can go to the power, and I'm going to change that to actually say this is the instantaneous or the power, right? And as you can see here, the legend is clear now what each one of those lines plots represent, right? And you can also, if I go on this menu here, you can zoom in or zoom out, or you can use the mouse. You can use your wheel on the mouse, see? And I'm zooming in, zooming out, and I can use this little hand to pan around, see? I can pan around and look for specific places, like if I'm looking for some specific information or so forth, like I'm getting to the top of my voltage curve right here, right? So that's all I see, but if I zoom back in place with the zoom, see, I can go back to my original figure. I can do things like three-dimensional, which in this case, it may not be, something that you want, but, and look at a figure like that, you know, give you another perspective, right? Go back to the original one, okay? I can select points here, like if I want to know exactly what this value is. Let's say I want to know, I'm going to zoom in a little bit, and I want to know where these two values intersect, for instance. If I click on here and I select this point here, see, I can see exactly where they're both intersecting, right? Okay, and I can select different points. Let me zoom back in. Okay, I can, if I right click on this data that I selected, I can delete that information if I want, if I don't want to see it anymore. If I want to keep it in my figure, again, I can just choose it to display it like that. And if I don't, I just, again, delete it, right? And I can have as many as I want, you know, select as many as I want, okay? So again, I'm going to delete it just to keep it a little cleaner here. All right. What else can we do? There's other things you can do here. In this example, for instance, I've got rid of the menu that you saw at the bottom, so it can give you a much clearer picture of what you're looking at. See how this actually looks nice. You can take this and either screen capture it or show it on a PowerPoint presentation or save it on a file for later and so forth, right? So let me go back to this menu here. And there's more properties here, more things that you can do. I mean, there's a bunch of other things that you can change, okay? And again, as we go into more into this, you're gonna use them a little more to make your plots look a little better. Other things I can do, if you look at figure properties, right? If you this shows you again, it shows you all the properties you can change. If I go to axis properties, if I click on the grid, I can see a grid for X. If I click on the Y, I can see a click for the Y and so forth, right? I can select the ticks, you know, how many I want and so forth for each of the axes. In this case, I'm only looking at the X, but I can be looking at the Y and so forth, right? So nice thing again, I can run this program and then generate the figures and then save it for later. So I'm going to close this, okay? And I'm going to close that figure. And I'm going to run this again just to, we can do another run of the script, right? So this time, let's enter a frequency of, I don't know, radian frequency of 125. And I'm going to enter a magnitude of 10 for the voltage, magnitude of 2 for the current. I'm going to enter an angle of 0 for the voltage and an angle of 45 for the current. And what you see here is what I was telling you before, is I didn't select or I didn't change the timing of this. The information is there. It's just that it's, you know, there's a lot more cycles that I'm seeing because I changed the frequency, right? So I can go back into the program and change the timing so I can see the information, but I can also, I might be able to use this information by zooming in and out. So if I zoom in, you know, you can tell where the information is, right? It's just that it's just constrained by the timing I have here because the actual frequency was a lot lower. the radiant frequency, right? So I have to keep track of this time for me to see. For instance, let's see what happens if I change that to 500. Okay, and I'm gonna run it again with those same numbers, or close to those numbers, right? Let's see. Let me just run it and see if that will improve things. So I'm gonna run it at about the 125 again. I'm gonna have, oops, sorry, wrong place. Gotta be careful here. It was meant to be here, right? So I'm going to enter the number 125. And again, I'm going to enter 10 for the amplitude, 2 for the current amplitude, 0 for the phase voltage, and 45 for the current voltage. See, I see more now. See? So you can play, I mean, because you know the kind of frequency you have, right? And again, you can make this interactively, okay? I don't have to go back into the script and do it. I can, and the ways actually later you'll see of you do this within the script without having to worry about changing those numbers. But let's just do, let's try from that to 100 this time and see what happens, right? We're just playing with it. So let me again run it. All right, let's see. So 125, I think it was 10, 2, 0, 45, doesn't really matter. But now see how I see now my values, right? Because I'm choosing the time so I can see the information, right? And you get the picture, right? All right, so that's the beauty again of using the scripts, okay? It gives you all that freedom to just do things and make changes on the spot and run them again. And they're very easy to do and very intuitive. And you can use them and reuse them all the time for things like this, right? Okay. Okay. Couple more things. I wanted to show you also the if-else end statement, which again is common to any computer language. If you use any computer language in the past, as I'm sure you have, this is just, it's the same thing. But I want to show you the use of it in a little script. And I have this little script here called force, and it is nothing more than a little script that calculates the force of attraction or repulsion between two charges. You remember this equation, right? F is the product of, or the force is the product of a constant K times the two charges, or the areas representing the charges, Q1, Q2, divided by the square of the distance, right? This is the equation that calculates the force of attraction or repulsion between two charges. So it's a simple equation, but I just want to show you, again, in the use of a script, a very simple if-else statement that will, let me get rid of this line here. I think we need it. Okay. So what I've done in the beginning is I define two constants. And by the way, this constant here, which is also important, I'm using exponential, right? Powers of 10. This is how you would write an expression to the 18th, 10 to the 18th. So I defined a coulomb. If you remember, a coulomb has this much number of electrons in it. We're not going to use the constant in this particular example, but I just want to show you, how will you define a constant, for instance, right? I have defined, however, one that we're going to use, which is k, as 9 times 10 to the 9. And if you remember, again, the e to the 9 means times 10 to the 9, okay? You can use an uppercase e or a lowercase e. It doesn't matter. It will recognize it as a power of 10. And if you remember, the units of k will be newtons per meter squared over coulomb squared, okay? So very simple expression. Again, we're not going to use a conversion from coulombs. We can use it in a later script, but just to show you how you define constants in any script. And then we're going to enter the parameters that we're going to need to calculate the force. K, of course, a constant. I don't need that. So we're going to input the two charges, and we're going to input the distance in the equation. And then we're going to calculate it. Now, this is where the if-else statement comes into place, right? So this is like any other if-else end statement, right? If this is true, then obviously this will be, this will take place. If not, then this one will take place, okay? That's all there is to it, right? In this case, I'm also introducing another function, which is the format function. And it's just a way of how I want the numbers to be displayed, right? So I'm choosing, just in this example, that if the force is greater than 10 billions, right, 10 to the 9th, and see how I use lowercase here instead of uppercase, it doesn't matter. If the force is greater than 10 to the 9th, then I'm going to display the answer using engineering notation. The short in ENG means I'm using engineering notation. But if it's not, if the force is less than that, I'm going to display just like a regular number, right? Not using engineering notation. And that's it. Very simple, right? So let me run this. And of course, it's asking me for the first charge. I'm going to put that 4. I'm going to the second one, 2 coulombs. And I'm going to plate the distance as 10 meters, right? And since the expression is less than 10 to the 9, it's going to display this as a long format expression. Let me run this again and run different numbers. I'm going to have 4 for 1, 4 for 2. I'm going to put 1. And now see how the force reduced the radius considerably from the previous example. And now the force is greater than 10 to the 9, so we wrote the, we'll put the force value in exponential notation, okay, in a short notation. So that's really a very just, quick example how you would use if, else, and, right? And in a simple script like this. All right, so you'll get a homework coming up after this lecture, and it'll consist of writing some kind of script. So make sure that you're understanding what's going on with the use of scripts and different ways that we can implement the if, else, the for, the input, the display statements that we have been using to show you this example. So we'll see you next time.